Toda. As we say in Israel, toda rabba. George, I will take the, Omer will take the clicker. Thank you, George. F. Charisto. Toda rabba. And now it's time for some double trouble. Double trouble, everyone. We've got a pair of speakers who share a first name and a passion for hacking databases. Now, this is going to be a fast talk by a dynamic duo, after which we'll enjoy another fantastic break. But I'd like to introduce you to our two fantastic speakers. I want you to give them a really nice welcome. This is Ofir and Ofir.
Hey, nice to meet you.
This is Ofir Balassiano, and this one is Ofir Shaty.
Yep.
I almost got it confused myself. It ain't easy. So Ofir and Ofir are really passionate about understanding how things work. Ofir Balassiano plays around on CTFs, Capture the Flag competitions. Ofir Shaty is a security researcher as well, and he has published groundbreaking research in the field of database attack techniques from both an offensive and a defensive perspective. And that's what we like to hear right here on this BSidesTLV stage. So Ofir and Ofir, dynamic duo, they're going to take us into the dark side of cloud-based databases and database engines. Ready to go? All right, take it away. Let's give a warm welcome to Ofir and Ofir.
Perfect. Okay. So, hi everyone. Thank you for being here today. Actually, we're very excited to be here. And today we're going to talk about how the shift to the cloud has changed everything we knew about database attacks and exploitation. So, today, when almost every single usage in the cloud involves at least one data asset, and every data asset has its own capabilities like backup, replication, different authentication methods, and so on. And when all these features kept to evolve, so do the attack landscape around them. And today, attackers have more possibilities than ever in order to get access to your data in the cloud. Before we'll dive into the technical attack vectors that we found, let's take a quick overlook about ourselves. So my name is Ofir Balassiano. I'm the head of research at Dig Security. In my past, I mainly focused on low-level research, and I analyzed hundreds of malwares. Today, my main goal is to protect your data in the cloud. With me, Ofir.
Hi, I'm Ofir Shaty, and I have experience with web application security and also with database security in the on-prem and also in the cloud.
Yep. By the way, we have so many Ofir in the company, so if there is any Ofir here, you can send me CV later. So what do we have for today? At the first part, we're going to talk about AWS Redshift attack surface and how Ofir and I were able to exfiltrate data and move laterally between different data services with almost single Redshift permission. In the next part, we're going to talk about our journey of discovering new vulnerability in GCP Cloud SQL and the way we broke the security layer on top GCP Cloud SQL and got access to the underlying host. So let's start. AWS Redshift, as we may know, is a database, cloud-based data warehouse, contains many features like backup, replication, IAM authentication, data share, and so on. And when Ofir and I wanted to understand the attack surface around it, we came across the following feature that we both thought it's a good example to understand how a misuse of a great feature can lead to risky ways. So the default IAM role gives you basically the ability to attach default role to your Redshift cluster. And from now on, the Redshift cluster will be able to interact with many other different data services on behalf of this role permission. So the attack scenario goes like this. Imagine that an attacker got access to your AWS account. It could be by a successful phishing attempt or any public credentials that they found. Now, the attacker got low-privileged stolen identity with two permissions: Redshift create cluster and the IAM pass role. Now, the attacker can create Redshift cluster in your account. But basically, they got access to many more data assets in your environment, such as EC2, RDS, DynamoDB, S3, and so more. Now, Ofir will continue with the actual attack vectors inside this scenario.
Thanks, Ofir, and hi, everyone. So in the following slides, we are going to talk and see some of the permissions that we have in the default role, and we will see how we can use them to our advantage, or our attacker advantage. So below me, you can see the permissions for S3 bucket. And between the permissions, we can see get object, list bucket, and many other permissions. We can do it on every resource or S3 bucket that include Redshift in its name. But I want you to note that actually when we created the default role, we chose the option of with no additional S3 bucket. But still, our policy include those permissions. So let's see how we can use it. So we will start with a enumeration with the copy command. But first, let's try to do the same with our original AWS principle. So trying to list the bucket, the object inside the bucket, we got permission denied. And now we will use the copy command. If you don't know, so the copy command allows us to load data from external sources into Redshift cluster. And we can do it from S3 bucket, from DynamoDB, EMR, and EC2. And to do so, first we need to create a table. We chose to create a table with the name exfil for exfiltration, which suggests what we are going to do with it. So we will use the copy command slightly different. Instead of putting the full file name that we want to load from the bucket, for example, in this specific example, we will put only the bucket name. And it will cause the command to fail. But behind the scenes, if we will query the STLload commit table, we will see all the file names inside this bucket. And this is how we enumerate all the files in the bucket without any permission that we had before to do so. Now that as attacker we have all the file names, we can start and exfiltrate them one by one. And to do so, we will use the same copy command, but this time we will use the full file name. And as you can see in the table below, we loaded all the content of the employee CSV file into the table, and we can see it. Now, if we would do the same with our original low-privileged user, we will get some access denied. Now, let's continue and explore more of the default role. So what we see here is the permission that our default role got for Glue. If you don't know, Glue is a service that allows us to easily integrate with other data services, for example, the S3, Kinesis, or Kafka. The permissions that we got here are create database, create table, and some other permissions. Again, for only catalogs or tables, Glue tables that include Redshift in their name. And yeah, another strong permission that our default role get is for the secret manager. And you probably ask yourself, why should we get, the Redshift should get permissions to the secret manager? So the answer is simple, to connect to remote sources. We can do it to connect to RDS databases, to Athena or Hive, and any other thing. So the permission that we get is get secret value for secrets that include Redshift. And also we get the permission of list secrets for all the secrets in our AWS account. Interesting, right? So now, if you remember, we had a restriction with the copy command that allows us only to load data from buckets that include Redshift in their name. So in this example, we are going to bypass this restriction. Here we will use the create external command, specifically with Glue. With this command, we can create external schema, as the name suggests, on top of different services. So we create external schema on the database called attack Redshift, and we will query the lake table. You can see below the Glue table. But behind the scenes, what happens is that the Glue table is referenced to S3 bucket, and the name of the bucket is Ofir Data Lake. And it doesn't include Redshift in the name. So this is how we can bypass some restrictions and get access to more data in our cloud. And here you can see some attack paths that we can do with our create external schema command. And if you want to see the full attack paths that we found for Redshift, you can go and visit our blog about Redshift attack vectors. Now, by this, we close our first chapter about Redshift attack vectors, and let's talk about some takeaways. So, as we saw in cloud environments, it is very hard to understand who has access to what. And we need something more sophisticated than iterating one AWS principal permissions. In our case, we were able to use a low-privileged user with almost single permission to single service, and we were able to access data in many other services. And this is not unusual in the cloud. Which brings me to our next takeaway, which is reduce your attack surface. Maybe it sounds obvious, but it works. And last but not least, monitor. We can monitor our environment in the cloud level, for example, with CloudTrail, and we also can monitor in the service level. In Redshift, we will use the audit log. And now I move you back to Ofir to talk about our next chapter.
Yeah. Yeah, right. So now, as promised, let's walk through our journey of discovering new vulnerability in GCP. First of all, let's ask ourselves, why Cloud SQL? Well, Ofir and I knew that the cloud provider, as any other platform, needs to do some modification and changes on top of the classic engines in order to integrate the classic DB engines into their platform. Moreover, SQL engine specifically is not an open source. So we knew that GCP couldn't just modify the source code itself. They had to build the security layer on top of the classic engine. And that leads us to our research question that was, if we can break the security layer that GCP built on top of the SQL Server engines. Well, to answer this question, we need to go back to some basics. So welcome to SQL Server 101. Every time that you will create SQL Server engine, 4 databases will be created by default. The first, the master database, contains mainly system objects. The second one is the MSDB database. We will talk about it later, but it contains mainly the SQL Server agent and scheduled jobs. The third one is the model database that is basically a template, and every change that you will perform in the model database will be affected in the databases that you will create from now on. And the last one, and it's our favorite, the TempDB, contains temporary objects for aggregation, SQL results, and so on. From permission perspective, we have the server permissions that gives you the ability to perform operations like create, alter, delete at the instance or the server level. For example, create new databases, alter logins, modify server triggers. On the other hand, we have database permissions that give us the ability to perform operations at a specific database scope. For example, create user inside the database, create new table. Keep in mind that the cloud provider would like to give us the minimum permissions that we need in order to operate in their managed databases. For example, only creating new databases and operating inside those databases. The minimum permission that we need in order to perform modifications on the default 4 databases. So, in this in mind, let's understand how GCP created its security boundaries on top of this architecture. To do so, we can ask ourselves some key questions. The first one is, who are we? And in SQL Server, we are operating as a SQL Server login. The next one is, what is our permission? And we're operating with the customer DB root role. The customer DB root role is a custom role that GCP created and does not exist in the classic engine. And the last one is, what does it mean, from our perspective, to operate with the customer DB root role? Well, it means that we are completely blocked. We have no permissions to sys objects, no permissions into the instance level. At this point, we knew that We are operating as the customer DB root role, and the first goal that we set ourselves is to escalate our privileges and to be able to run as a sysadmin. To do so, we can follow some best practices. For example, always know who we are, what is our permission boundaries, what we can and can't do. The second part is to enable audit. It was really helpful by understanding the indirect impact of our actions in the DB. The third one is to search for background processes that are running with elevated permissions that we can utilize. And the last one, and the most interesting, is to try to find some differences between the classic SQL Server engine and the modified one. Okay, so, well, it sounds easy. Well, we tried. Believe me, we tried a lot. And after some coffee shots, we came across the following screen in GCP. We saw that we can't see only our SQL Server login, we could saw internal logins too. And not only we could saw them, we could change their password. And moreover, we could enable them on the MSDB database. At this point, we knew it was our first step toward our privilege escalation, because at the first time, we could operate with other permissions that we started with. So like a good researcher, we started by playing with our new brand permissions and trying to create some custom jobs. And while doing so, we saw a job that GCP created called add tempdb permissions. This job runs every time that SQL Server agent is restarted. And basically what it does is runs a simple SQL query that gives us, the SQL Server user, a control permission on the temp database. Control is the highest permission that we can get at the database scope, and it gives us an idea. What if we can create a database trigger inside the tempdb, because we have control of the tempdb, and find another user that will pull the trigger for us, and then we will be able to run our code inside the trigger with the elevated permissions.
Yeah, so with database trigger in place, we only need to find this background process that will execute with higher privileges and take some action on the tempdb that eventually will grant us with a sysadmin. So we went to our audit, our dearest friend, and we walked through hundreds of thousands of records until we came across this special record. And what we can see here is actually a create user. When we created a user from the GCP console, this audit record was created, and the user have been created in all 4 system databases, including the tempdb. And what's special about this record is that the principal that actually take this action is Cloud DB SQL root. And we were surprised when we saw it. So if you didn't guess what happened just now, so we will let's take a recap. So we created a trigger on the create user event, which will call a function that will grant us with sysadmin privileges. Then we go to the GCP console and created a user, which we know that behind the scene is done by a privileged user. And the user pull our trigger and grant us with sysadmin. Okay, so not sysadmin, but DB root role, which is pretty good. And let's do a quick status check. We wanted to get to sysadmin, but we got only DB root role, so we have path to go. But let's see what we have. So on the left side, we can see the privileges, the original privileges that our SQL Server user has. We can see around 12 privileges, around them some view permission on the server, some connect and insignificant alters. And after our privilege escalation, we can see that we have a couple of more permissions. But more importantly, we have the control permission, which allows us to, which is the most strong permission that we can get on the SQL Server. But it's not enough, because since we are not part of the sysadmin role, we are still impacted by deny statements. So this is not a real full control. But look at this interesting permission. We also have impersonate any login, which is our door to our second privilege escalation. We impersonated SA and granted ourselves with sysadmin. And now, acting as sysadmin, we started to find our path towards command execution. So there are many known techniques to execute code on SQL Server. We started with CMD exec in the SQL agent. We tried PowerShell. We tried CLR assemblies and XPCMD shell. But unfortunately, none of them worked, because for our surprise, we were running over Linux. More specifically, a Docker version of SQL Server. So we had to try harder. And as sysadmin, we have full control. We could read all the files in the file system. We started to extract secrets and passwords. But at this point, we got a surprising email from the GCP team that asked us to stop our research. So we worked together with Google to disclose the vulnerability. And actually, we found it on February, and by April, the 2 vulnerabilities was fixed. And by that, we close our last chapter about the Cloud SQL vulnerability. So it's time to sum up. First of all, Google are awesome. No, but for real, they gave a very quick response and fixed the vulnerabilities very, very quickly. And we saw that in the cloud, the cloud brings new attack vectors to the table. We saw in this presentation 2 examples for different kind of attack vectors that can be utilized in the cloud. And while not everything is in our control, like cloud provider vulnerabilities, we saw some attack paths that are in our scope. And the main point that I want you to take with you from this presentation is that our data in the cloud has many paths to it. And it is, so it has many paths to it, and not all of them are obvious. And attacker knows it and use it. And last, I want to talk about the security in layers. So security in layers or in depth. We saw such good example for security in layers with GCP, where they implemented the Docker inside a VM. But it also highlights the importance of permission management, the fluidity of permissions in the cloud. So it emphasized the importance of good cloud architecture and permission management. Thank you all for listening to our talk, and I hope you enjoyed. And if you want to learn more about the topics that we just discussed, feel free to go to our site at Dig Security.
Thanks.
All right, all right, all right, all right.